This is video number 4, significant figures and operators. We're going to do operations with significant figures, very commonly add, subtract, multiply, and divide. When we add and subtract, the rule is that the leftmost position of uncertainty determines where we're going to stop. And I'll show you what that means, leftmost. So we have a value here like 15.4 grams, and we're adding 8.20 grams. What we're going to do is line it up like a third grader would. And that's the easiest way to see it. So if I have 15.4 and I'm adding 8.20, both of these have 3 significant figures. There's 3 significant figures here and 3 significant figures here because trailing zeros are significant if there's a decimal point. Now when I go through and add, it's not the number of significant figures that determines how many significant figures in the result. They may be the same, they might not. So in this case, my uncertainty is on this 4. Maybe this 4 is really a 3, maybe it's a 5. We're not certain because the last digit of any measurement is uncertain. The uncertainty in this data point is the 0. Maybe it's a 1, maybe it's a 9. We're not sure. But we are sure it's not a 5 or 6. And that's what that information that's given us. So when we add up, we're going to stop at the leftmost position of uncertainty. We go through here, we'll have 23.60. You'd say, well, the uncertainty is in this 4, therefore this 6 is uncertain. We're only going to have one uncertain digit in any measurement. So that 6, maybe it's a 7, maybe it's a 5. Once we determine it's uncertain, we're going to truncate the back end. If it's 5, less than 5, greater than 5, we'll round up. So our answer here is going to be 23.6 grams. Now, if we're doing the subtraction here, we have 10.04 grams minus 4.2 grams. You can see here we have 4 significant figures. Here we have 2 significant figures. So we take this and line it up like a third grader. 10.04 and then minus 4.2. Okay? So my uncertainty here is in the 4. Maybe it's a 5. Maybe it's a 3. The uncertainty here is in the 2. Maybe it's a 3. Maybe it's a 1. So when I do the subtraction, I'm going to get 5.76, 5.84. So I get 5.84, okay? And you go through and you say, all right, my uncertainty, this 4 was uncertain, but so is the 8. The 8's uncertain because this 2 was uncertain. Therefore, my uncertainty is here. I'm going to truncate that off because it's a 4, and my answer is 5.8. 2 significant figures in the final result. So in summary, with addition and subtraction, we're going to add them up, line them up. The leftmost position of uncertainty is going to determine the position where we're going to stop. Now, multiplication and division is actually simpler because all we're trying to do is maintain the fewest number of significant figures. So if I'm multiplying 2 values, 1.5 times 10.0. When I go through and do this multiplication now, I have 2 significant figures here, 3 significant figures here because of the decimal. So my result needs to have 2 significant figures, regardless of how it's constructed. So I'm not looking at position of uncertainty like I am in addition and subtraction. I'm just looking at the number of significant figures. This is going to be my final number. Therefore, when I multiply this out, I'm going to get 15. I could say 0.0, but I only want 2 significant figures, so I'm going to stop there at that position right there. Division works exactly the same way. We will limit the answer to the fewest number of significant figures in our data points.